Today we're going to do the task 1, which is entitled the Choose coenzyme.
The notable materials that we are going to use are meat tenderizer, baking soda, and of course, 1 piece of apple. First, we need to peel the apple. After peeling the apple, we will cut it into smaller pieces. We needed to be careful not to cut yourself while cutting the apples. After cutting them, prepare the pan and put it on a low heat. Put the apple first and then put a cup of water. We will then put it into a simmer for 20 minutes. Fruit cells die and undergo dramatic changes when heated, causing them to leak water and soften. Furthermore, you can deactivate enzymes by dipping cut apples in boiling water. After 20 minutes, the apple softens and I smash it with the use of fork to make a puree. In a separate bowl, I added 5 tablespoons of meat tenderizer. Next, I pour 150 ml of water and mix the solution. As you can see, the meat tenderizer dissolved in the solution and white cloud appeared on the surface of the solution. On another cup, we will also make a baking soda solution. The baking soda does not fully dissolve. Finally, we will put 3 tablespoons of puree in a container. Add the 5 teaspoons of baking soda solution. We will then pour a cup of meat tenderizer solution and mix it. For filtering, I use layered gauze pads and put it on top of a container. Pour your solutions into the filter and let the liquid pass through while the solid particles stay unfiltered. On the time the liquid was filtered, it appeared as viscous with tiny granules spread throughout the solution. After 10 minutes, to my surprise, clump particles were seen on the surface. Some of it was shaped like a circle and they were numerous. You can also see it in the solution that on the bottom part, it was clearer than the upper part of the solution. Hi, I am Queenie Faye Ihipto, BSMLS 2A, performing Task 2 in Module 4, titled What Keeps Them from Browning? The materials that we are going to use are apple, onion, calamansi juice and cooking oil, baking soda, half cup of water, labels for the container, spoon, teaspoon, knife, chopping board, and 5 containers with lid. The first thing to do in this experiment is to cut the apple into 10 cubes in the same sizes. Next is to label the 5 containers into controlled, water, oil, calamansi juice, and onion. Then prepare the container and place 2 cubes of apple in each container. After that, using a spoon, place the prepared substances onto the surface of the apple. Set aside the container and prepare the baking soda solution by adding a teaspoon of baking soda in a half cup of water. Afterwards, add 5 teaspoons of baking soda solution in each container. Lastly, keep all inside the refrigerator overnight and compare the apple cubes in terms of browning after the set time. Rank them 1 to 5, in which rank 1 as the extensive browning. The night has passed and the results are these. Rating the browning of the apple with the various substances plus the baking soda solution, with rating of 3 for the container with oil and water because these apples have the most obvious browning, followed by a 4 for the onion and control with minimal browning of apples, and 5 for the container with calamansi juice as there was no browning. Prepare 4 transparent cups that contain 1/4 cup of hydrogen peroxide. Cut the onion, potato, apple, and pineapple into cubes. A reminder that the 4 samples should have the same size. Next is to prepare the baking soda solution. In a half cup of water, pour 1 teaspoon of baking soda and stir it gently. Place the samples in the hydrogen peroxide solution. Then add the 5 teaspoons of baking soda solution to each cup. Notice that the solution changed its color to yellow. Finally, observe the changes. After a minute, tiny bubbles were visible in each solution. After 5 minutes, the bubbles in the onion were moving towards the side of the container, whereas the potato continued to produce bubbles, and they were visible on the surface of the sample. The apple, on the other hand, did not show many bubbles. However, the bubbles were sticking on the surface of the sample, creating a white layer on it. Furthermore, the pineapples showed the most noticeable changes, for its bubbles settled on the surface of the solution, in which it created a clump of bubbles. Moreover, after an hour, the bubbles in each sample became more prominent and noticeable. However, the pineapple solution changed its color into visible white. The apples showed brown colors on its surface, particularly on its center. The changes in this sample are due to the presence of enzymes present in the different samples. Onions contains enzyme called alliinase. Catalase is abundant in the potatoes. Hence, the creation of bubble was continuous in the sample. On the other hand, the apple contains the enzyme called polyphenol oxidase enzyme that gives the fruit brown color. Moreover, pineapple has a bromelain enzyme.
Good day, I am Kirsten Balcazar and today I am going to perform task 4 entitled Magic Bubble.
The materials needed are potato, baking soda, vinegar, measuring cups and spoons, plastic cups, water, and hydrogen peroxide. To begin with, let us label the 4 plastic cups from 1 to 4. Next, transfer 1 sachet of vinegar in a spare cup. 5 teaspoons of this will be poured in cup 1. On the other hand, prepare 1 teaspoon of baking soda to be mixed in a half cup of water. Subsequently, scoop 5 teaspoons of baking soda solution and pour it in a cup of number 2. With the use of timer, soak a strip of potato to each cup for 5 minutes. While waiting for the time to end, prepare 5 teaspoons of hydrogen peroxide to be poured in cups 3 and 4. Finally, after 5 minutes, transfer the strip of potato from cup 1 to cup 3 and pour 5 teaspoons of baking soda solution. As we can see, noticeable changes in the color of the solution were evident. A clear solution of hydrogen peroxide was turned into a yellowish solution after the addition of 5 teaspoons of baking soda. The changes in the color of the solution were due to the presence of enzymes carried by the potato. Meanwhile, this strip of potato from cup 2 was also transferred to cup 4. After the addition of 5 teaspoons of baking soda solution, the same reaction in the appearance of the solution occurred. At closer look, small bubbles from cup 3 and 4 were observed. In this regard, cup 4 has the most consistent bubbles. However, when I tried to use a smaller strip of potato using the same process, the yield was even more evident to the naked eye. In cup number 3, the presence of bubbles were visible, but it slowly faded out as time passed by. The presence of vinegar carried by the potato and the hydrogen peroxide resulted in the peracetic acid, which in turn mixed with baking soda solution. Hence, these reagents are responsible for the bubble formation. On the contrary, the solution present in cup 3 yielded more evident results because the reagent's baking soda solution contains more volume when it begins to react with the hydrogen peroxide.
Good day everyone. Today, I will be performing an experiment called clot for milk. I am Frances Elisha F. Bakiran from BSMLS 2A and we will be performing the Model 4 and I was tasked to do Task 5. So these are the materials that I will be going to utilize in the experiment. First is the fresh milk. Next is the measuring scoops and measuring cup, stick for stirring, plastic cups, vinegar, and pineapple.
Task 5. Set aside each cup after pouring 100 ml of milk into it and squeeze the pineapple pieces to extract the juice. We'll go back to the 2 cups of milk for the following step. Measure 1 teaspoon of pineapple juice and put it in the cup of milk on the left side. Continue on the second cup in the same manner. Add 1 teaspoon of vinegar after a teaspoon of pineapple juice has been poured. After that, carefully stir both solution and set a timer for 5 minutes. There were no visible changes as I poured the pineapple juice into the milk. However, as time went on, the milk containing pineapple juice and vinegar began to form clumps. The milk with only pineapple juice had no changes in the appearance after 5 minutes. When you add pineapple juice to the milk, it's supposed to clump. The pineapples in the enzymes, not the acidity, are the responsible for the curdling of the milk. The amount of pineapple used, however, was insufficient to break down the casein proteins in the milk and dissolve their micelle structure. As a result, no substantial changes in the solution were observed. The solution with milk, pineapple juice, and vinegar, on the other hand, showed a noticeable change. The milk had clumped together in a very evident manner and the surface of the mixture turned watery. This is because introducing an acid such as vinegar to milk affect the pH or acidity of the latter. and causes the casein molecules to unfold and rearrange into a long chain, causing to milk the curdle.